Hey everyone, welcome back to the second video. In the first one, we saw how we can cycle through LEDs on board a Seed Studio XIAO BLE board using Embassy and Rust. If you have not watched that video, then I suggest you do that. I will link that in the description below because this example basically builds off of that. So I will skip the parts and the boilerplate that I explained in the last video and just go straight to the example that we have today. So today we are going to do digital input and we are going to use a button to control an LED. So I have initialized the red LED as we did last time, and to use the input we need something like this. So we use the input from GPIO and then we have to specify if it's pull up or pull down. So we are specifying pull up here because we want the button to float in the high state when it's not pressed, and when we do press it, it will go low, and we will be able to then use the isLow method to see or to perform whatever action we want to perform on it. So in the loop, we will simply do polling this time. So all we're doing here is checking if the button is low. If it is, then we turn on the LED. If it's not, then we just simply turn it off. So let me just run this example and see how we do. I am going to bring up the screen now. Okay, so I'm going to press this button, and as you can see, the LED lights up. So this is how we use input in Embassy. Now I should mention that this is a bit inefficient because we are constantly checking the state of the button, and if it's not low, then we are basically just wasting CPU cycles, and this can be very inefficient. To demonstrate this, I will just put a logging statement here that says pressed, and then another one here that says not pressed. So let me just refresh the code. I'll bring up the screen again. So as you can see, the button is not pressed, but we are still wasting a lot of CPU cycles on checking if it is pressed or not. And only when we press the button, we actually run the logic that's supposed to be run. So I think you should be able to understand why this is very inefficient. And we will this is what we will fix using interrupts in the next video. That's it for this one. If you liked it, give it a thumbs up, and I'll see you in the next one.